So what I will do in this keynote, the role of this keynote is to provide a framework. Really, what I'm much more interested in is your questions. So, but I've got in a way a duty with this 25th anniversary. There's a reason that the World Wide Web Foundation set about celebrating the 25th anniversary and put together this logo and put together all these events. It's not just to have, because it's good to have a party, but it's because there is a serious concern about the future of the web. I'm sure you've already had lots of discussions about the future of the internet. The question that we've been asking is, the World Wide Web Foundation has been asking, is what is the web we want? Okay, it's www as well. There's webwewant.org you can go to. And in those discussions, we've been trying to get people to think, this year we want to use the 25th anniversary year to get people to really think. People like you may be thinking about the internet and how it works and about the policies around it a lot of the time, but we want to get more people who wouldn't normally think about it to consider what sort of a web they want. We did this, we decided to do it. In fact, a couple of years ago, we picked on the date, but that was before Edward Snowden revealed what he'd found out. So that since then, there's been, to a certain extent, a lot of focus on certain aspects of privacy on the web, certainly. But there are a lot of other aspects. And in a way, I'd like you to end up thinking a lot about what rights do I have as a network user. But so to put it in perspective, yeah, 25 years ago, of course, a lot of people in a lot of places it's quite difficult for people to understand the difference between the internet and the web. 25 years ago, it was not difficult to understand it because the internet had existed for 20 years. The internet started around 1969 with Vint Cerf and Bob Kahn connecting. They had local area networks, and they thought, hey, it would be good if we made connections between nodes on each of these networks, then we'd be able to connect them together into an inter-network. And so the inter-network was what they created, and they designed the IP protocols. And so that from 1969 through the 70s, they had a network where you could write a program on one computer and without really worrying about the details, have it communicate with another version of your program running another computer. And over that time, people had made internet, had put email, they'd moved it from being a mainframe-based system to putting it on to running over the internet. They had file transfer protocols, so you could connect to another site and access the file system on it interactively, and they had telnet, so you could log on to another site. So all of these were, but telnet and FTP were quite geeky. So the situation then 20 years ago was that I was sitting at CERN. I was not, by the way, officially doing this project. My boss, Mike Sendel, let me do it on the side as a sort of as a play project, because CERN didn't really have a budget for making global hypertext systems at the time. So I'm not sure it does now, actually, because it's, after all, a physics lab. But what was really nice about I suppose two things made it possible. One is Mike Sendel, my boss, said, okay, clear about a time, why don't you have a go at this project? Buy one of those cool new Next machines. Anybody remember a Next computer? Those black boxes? Yeah, okay. These are the people who were around 25 years ago and adult 25 years ago. Most of you clearly don't. But that was a really cool, the Next machine was a really cool box. And actually a lot of the software on it is the software you have in the iOS development system at the moment. So it had good, cool development tools, and we decided to use it. So one was the fact I got permission to do it as a side project. The other is the way the internet had been put together. The internet had been put together as a platform so that I could just write a program that ran on one machine. And I could write a web server, which then was very simple. And it's still pretty simple, but not quite as simple. And then I could write a web browser, which was also quite easy using the Next because it had a lot of really good existing object libraries. And I could just set it running. I had to communicate. It had to know the IP address or the domain name system. The domain name system was all there, so it could know the domain name of another computer it wanted to talk to. And you had to pick a port number. Initially, I chose 2784 because it was my parents' telephone number. So that's all you need to do to communicate across the internet. That is the wonder of the way the internet was built, as an open platform. It was completely decentralized. No need to go to a central hub. No need. I didn't have to go to Windsurf and Bob Kahn to say, "Hey, I want to use your network. Can my protocol be connected into it?" So actually, well, to get a nice small port number, you did have to ask somebody. The people who did Gopher, the competing protocol, who had port 79, were very jealous when I got port 80. So the reason that HTTP runs on port 80 was because that was the next in line from the people that dished out the port number. So in a way, the internet was a centralized system from the point of view of I had to get the port 80 to get a nice small number. It was a centralized system from the fact that the domain name system was centralized, although we didn't worry about it then like we worry about it now. The web itself is designed as a completely decentralized thing. You don't have to register a new server, you can write a new browser, the whole thing, anybody can build a new website. That was the idea. The original code which I made was not just a browser, but it was an editor. The Next Step software has a text object, which is an editable text object. And I enhanced it to make it be hypertext, give it links. But the whole idea of this was that you'd be able to, if you were reading a page, and then you could just highlight a piece of text and link it to another page. Highlight two pieces of text, mark one, and link to the other, save both of them back, and you'd have contributed to the web. It was designed to be very, very easy to contribute to the web, and it was supposed to be a read-write space. Oop. Do I need that? Okay. So that is the history, and I'm emphasizing in that the way the thing was designed to be decentralized, both socially and technically, was really important. And apart from and if you look back at the history of people using the internet, the fights over the domain name system are where the problems have been. Yeah, we've got a problem getting from IPv6 to IPv4 to IPv6, but that was because of an unfortunate mistake they made in making the address space too small. But the IPv4 has worked really well. All of the battles have been about the fact there is one root to the domain name system. So the one centralized part of it has been the issue. Now, so yeah, Jean-François got involved when people came to me who were in the industry, and they said they wanted to be able to work on the standards, the protocols, as open standards together. They didn't want to just wait for me to invent the next one. They wanted to be involved. So we had to start some sort of consortium. Inria and MIT were two of the hosts of the original consortium. And MIT is, now RCIM is a host in France. And also we have KO and now a host also in China. So it's very much of an international thing. So the reason that the technology continued to expand and to continue to be to get more and more powerful is while remaining open, so that anybody could build a web browser, anybody could build a new search engine, anybody could build a new cool website, is that it was still decentralized. The web was still built technically as a platform on which to build things. Like the internet wasn't designed for any particular application. The web isn't designed for any particular application. Also, Robert Caillou, my colleague at CERN, and I had gone to a lot of trouble to go to CERN and ask them to make sure that they promised that they would not charge royalty fees. That was a massive thing. There was I mentioned that other project, Gopher. There was a competing wide area information system, and the Gopher protocol, when you looked at the backbone traffic, the back Gopher protocol was increasing exponentially at that point. But when it got to the World Wide Web protocol was lesser. And then at a certain point, the University of Minnesota they sent around an email which said, don't worry about this if you're academic, only if you're a commercial person. And don't worry about this if you're running a client, only if you're running a server. And then, not now, maybe later. And then, but possibly, if you're a commercial organization and you're running a server, possibly later, we just might, not necessarily, but we might charge a small fee. Yeah, so people, the World Wide Web continued to grow. The World Wide Web continued to grow. Gopher died. At that point, everybody looked at it and they said, wait a moment, I'm not working for the University of Minnesota in my garage. And the company and people who worked in big companies. Also, you worked for IBM. If you work on a project which has got intellectual property from some random university, then maybe you'd have to leave the organization. It could be a firing offense to, I don't know whether it would have been in IBM, but in a lot of software companies, they can't afford to have a programmer's brain polluted with something which requires royalties, which is patented. So keeping it royalty-free, and that's one of the things that the consortium did as well, as all these companies came together with Jean-François as president for many years. One of the things that we kept was this rule that the standard will be royalty-free. So that's one of so the web, when we look at the web we want, the web I want is one where we continue in the future to make things royalty-free. Companies you work for, you may have lots of great ideas, and whoever you work for, maybe a university, maybe a company, they may be very keen on getting you to patent things. They may be where they want to establish a portfolio of great intellectual property. Make sure that you have a deal with them when all you put the creativity you put in. If it's going to go into network protocols, if it's going to go into the sort of thing which, if it's going to work, everybody has to use the same protocol, then make sure that you've got a commitment from the people you're working for. Make sure you make your own commitment to yourself that when this goes out, it will be royalty-free. So that's been really important. So the web the technology has grown. HTML became more powerful. Obviously, when I originally wrote it, it only had half a dozen tags, sort of H1, paragraph, and anchor. It now has a lot of tags. Originally, it was a very short web page. Now, it's a very long web page, and if you print it out, the HTML5 book is pretty thick. It's got lots of really good things in it. It's in a way, it's turned it into a language for doing sort of everything, but which is okay. It's not as simple, but it's very powerful. Originally, I expected it to be only used for sort of the pathways around the web, and I expected the actual value to be in documents in other formats. But no, people used HTML for the documents. So it's become a powerful document language. But over the last 25 years, there's been one major change bit by bit. It has changed from a web of static documents to a web of programs. When I was a kid, my parents actually met while designing one of the very early computers. The first commercial computer made in the UK, it was called the Mach 1. It came out of France University. What they were excited by was the idea that you had this programmable thing. The Turing result was that if you have one computer, if I have a computer and you have a computer, and you make your computer do something, well, I can program my computer to emulate your computer, and then I can make my computer do anything that yours will do. The Turing theorem makes all computers equivalent, and so it throws down a challenge to any programmer. Wow! In a way, there's no fundamental limitation. Well, there are some fundamental limitations, but very few fundamental limitations to what a computer can do. Therefore, the limitation is only in the imagination of the programmer. So if you can imagine doing it, then you should be able to do it. And then back then in the 50s, they imagined that they would be translating from Russian and from English to Russian and back again. It didn't go so well. No, still not quite there. But but they imagined all kinds of things, and a lot of them they did. But the message then was, hey, if it's programmable, if it's Turing complete, then the challenge is up to you to imagine what to do with it. And I'd really encourage you, of course, if, that's a sort of 50-year-old message, but it's still a really good one. Now it applies to web pages, okay? You can make a web page, and it's very wise and a good idea to make great websites with static, simple HTML pages, or web pages which are generated automatically by the servers and are simple, plain hypertext. That's still a very valid medium, but now because each one is a program, then each one is a JavaScript system. What's coming through the Web Consortium, and I think Fabien is going to talk about it a bit later, so I won't go into great detail, is the power for that, the program running in your web page, to be able to access all the features on your computer. If you buy a program that runs on your desktop, on your laptop, then it can access the camera, it can access the network, it can access memory, it can access memory of different sorts. In the phone, it can access the GPS and the accelerometer. And so what's happening now is that the program in a web page can do all that. So this is a huge new platform. The Open Web Platform is a huge new base, so that if you're going to be creative, instead of programming just programming a computer, you can program a web page, and you can have all that power, except now it will run suddenly on millions of different people's computers. And those computers, those web pages, can talk to each other with RTC, web real-time communication. So you can set up a peer-to-peer network between all these different versions of the same web page. And that is really cool. You can set up video conferences, you can set up audio conferences. This is sort of cool stuff coming down the pike, coming through the consortium. By the way, do get involved with the work in the consortium. A lot of people here, maybe a lot of people around here are involved in the consortium. Take your latest idea. You can start a community group. It's very, very easy to do. And we need all the cool latest ideas that you all have, not just all the old boring ones that people in my generation do. So lots of cool things coming down the pike. I've talked about the decentralized systems. Let me talk a bit, I've talked about the openness, the platform. Now let me talk a bit about the social side of it. I suppose when anybody designs software to run on the internet nowadays, they realize that they're doing something social. And in fact, if you think about the design of the web, there's the hypertext part of it, there's the HTTP, but also there's the part that the human being plays. The human being, why do people make a link? Because they make a link because they want people to follow a link. Why do they want people to follow a link? Well, they want people to follow links from their web page because they want people to find the web page useful, because they want other people to recommend the web page by making other links so that they get more readership, so that they get more kudos, or so they get more money. So there's all these processes now behind why people make links are connected to the technology of how they make links. The mail system was designed worked very well in an academic environment where everybody was friendly. And back in those days, there were only academics on the network, and they only sent email to each other if they thought that the other person would want to read it. There was no advertising, there was no commercial use. When the National Science Foundation flipped the switch and said, okay, it's all right to use the backbone, the NSF backbone for commercial use, they did not change the protocol. If they had been very, very smart, they would have said, let's look at any protocols. When we have a different business model, let's model what happens. And let's change SMTP so that when people use it, when it's used commercially, we can put things in to be able to protect us against spam. But they didn't. And we have a huge spam explosion, which we're still suffering from. So everything is social as well as technical. Everything you design is social as well as technical. There's always social components, even if it's not just social networking. And underneath the rules of the road, the rules of the road of the internet were, I put packets in, they go through and they get picked out the other side. The rules of in those days, a router, all you could do, if you build a router, that's all you could do, is packet comes in, figure out where to send it on like a postcard at a post office, because the computers were slow and the internet was faster, we didn't have time to do other things. Now, the computers are very fast, so if I'm a router, I can look at a packet, I can open it up, I can see what conversation it's part of. I can realize it's part of this person who's requested a web page from this server, and I can look at all the pages, all the words in the page they're looking at, so I can spy on it. So now, with deep packet inspection technology, suddenly the internet protocol seems to have changed. Instead of deliver my packets, it's take my packets apart, figure out what I'm doing, spy on it, compile a database of it about me as well. That was not in the deal. All right. And a lot of people were very unhappy with it because a lot of the assumptions they'd made about using the internet, all the wonderful things about being able to have that conversation with somebody a long way away, somebody that you love a long way away, who, as though they were in the same room, well, suddenly it's not as though they were in the same room. It's as though they were in the room, but there's two police officers and somebody in a military uniform there with a tape recorders there in the room between us. Okay, so it turns out that when we define new protocols, when we think about the future of the web, we need to think about lots of social aspects. We need to think about the right to privacy. Obviously, there's been a lot of discussion about that since Snowden. Let me see, how much time have I got? So there's been a lot of discussion about privacy since Snowden. Also, people before Snowden, if you ask people what they were worried about on the internet, a lot of them would have said censorship, because at that time the evil figure out there was China and the famous Great Firewall of China. So China blocks. If you go to China, you can't get to it. When I was there last, you couldn't get YouTube or Twitter, but you can get Vimeo. You can get some things, you can get others. Some people think it's political blocking, some things commercial. They block Google, but is it because they don't want Chinese people to understand what's happening in the world of Google, or is it that they want to promote their own search engine? For one reason or another, though, there's censorship. Censorship, it happens to a certain extent in lots of countries. There's been a lot of discussion in the UK. In the David Cameron introduced censorship, so that when you set up an internet connection for the first time in your house, you have a question: do you want to have child protection turned on? And the default is yes, please. I want to be protected from pictures of people with no clothes on. I want to be protected from including things which may be politically subversive. There's a line in there, I forget exactly what the line is, but things which may be, things like sort of terrorism sites, and that's where it gets a little bit. Now, but you can turn it off. You can, but of course, somebody has a list of all the places where they've turned off the filtering. People like me turn off all the filtering immediately. That was, I suppose, the result of a debate in which people in the UK had reasonable feelings in both directions. They wanted to have a certain amount of protection from sites which were really criminal and malicious, and certainly things like child pornography. I think people agree that's illegal pretty much everywhere. So censorship is one thing, but when you compare censorship with spying, it actually looks so the spying is so much sneaky. The spying is if instead your oppressive government allows you to go to the website that it doesn't like, it allows you to go to the subversive site, allows you to go to the site of the other competing party, which is threatening to overthrow them, and it just lets you do that, and so it clocks your usage of the site, and then it spies on you, gets your passwords, logs onto the social network, so as you finds out who your friends are, monitors their communications. And so that is much more insidious, because then you and all your friends can disappear in the middle of the night with no warning. You never realized that, you never got the notice saying this website is blocked. If the website is blocked, you can start a discussion about it. If your access to the web is spied on. So clearly we have a need for our law enforcement agencies to be able to have powers to investigate things on the internet. But clearly we haven't in the UK and haven't in the US certainly managed to find a good way of demonstrating that those powers are used in an accountable way. So that, I think, will be a lot of interesting discussions in the light of the Snowden revelations, but they were good discussions before Snowden as well. And it may be that the governments that you know end up taking a position where they have too much control. Maybe it's a government that you quite sympathize with takes a position where it has a lot of control. Maybe they put in a system which you would be horrified if it were used by another government in the same country. So be careful. Don't just assume that the systems that you put in place are going to be used by the current government which you sympathize with. And in the end, of course, there have been laws which people objected to, like SOPA and PIPA in the US, and the ACTA agreements in Europe, where people went into the streets, and you are of an age for protesting in the streets. If you don't like it, do that. Go out there, change yourself to the railings. It's still in fashion, and it's had a huge amount of effect recently, in fact. And when it came to the SOPA and PIPA, the rate at which members of the US Congress changed their minds about whether the SOPA and PIPA were a good idea, so realizing they were a bad idea, was phenomenal, and because of the public demonstrations. So be alert and protest when you think the rights are being, your rights are being infringed. Think about what is your right. Okay, so you'd like the right not to be blocked. That's easy. You'd kind of like the right not to be spied on, or maybe, well, okay, not to be spied on except by a police officer who's gone through a very well documented and well overthought some sort of process with very good oversight. But also there are other things which we can do all the time, which sometimes we forget are sort of rights that we rely on. Like, for example, if I connect to the internet and you connect to the internet, we can communicate. That's the way it works. Sometimes there are problems because actually you're a site which has got some really cool independent films, and I've connected to the internet in America through a cable company, and the cable companies in America are used to selling me movies. They send me a list of all the movies that are on this week. And so somebody in the cable company realizes that if they slow down my connection to any of the internet movie sites, then I'll be more inclined to go and watch their pay-per-view cable, which has got 300 movies tonight. Now, of course, they can't compete with their 300 movies, but it's very important also that the competition for movies should be open, that the market for content, the market for services, the market for using the web must be separate from the market for connectivity. So that rule we call network neutrality, that the network will deliver packets without discrimination commercially, without discrimination politically. So net neutrality has had a lot of people trying to push back on it from the big telecommunications companies, because they would love to sell you a laptop. They'd love to give you a laptop. They'd like to give you a tablet for free, which has got built-in Wi-Fi, built-in LTE, and a built-in search engine, where they control the search engine, and they control which newspapers you go to, and they control which movies you watch, and they control at the end of the day where you buy your shoes. Because if you can control somebody's access to the internet, you can control their life completely. And just recently, somebody was commenting. There was a paper we had at one of these Web 25th events. We had there was a paper which somebody pointed out that Facebook is starting to give you news as a function of an algorithm. So for millions of people out there, as they log on and they find out what their friends are doing, Facebook is telling you what their friends are doing. And of course, their friends are doing a lot of stuff, and lots of stuff is happening out there. And the social network, not just Facebook, any social network has the ability to, has to make some decisions. Now, which friend shall I tell you about? If we're coming up to an election, of the friends, you have some friends which are leaning to the right and leaning to the left. Maybe, and if the social network starts just slightly producing a little bit more collaboration between the people who are leaning in one way than the other way, then maybe the social network, just by making a little tweak in the algorithm, you could end up making a huge shift in the electorate. Maybe you could end up making a shift which will end up sort of becoming a chaotic, massive change, which will end up pulling people's ideas about evolution, religion, whether to vote left or right, over from one way or another. So there is a huge power in social networks. There's a huge power in the search engines. So what do you want in the way of rights there? Do you want search engines that know you really well and end up giving you brilliant answers when you're trying to do your homework, you know, when you're trying to find presents for your family? Then do you want a search engine which says, "Oh, it's Matthew's birthday. This is what he needs. Trust me." Okay, and he's right every time, you know. Or do you want to have an option between that one, which is going to say, when you search this on the web, I'm not going to use any information about you at all. I'm going to tell you what the world is currently saying about the topic, in general. No bias. Not France, not anything. I'm going to forget the fact you're in France. I'm going to forget the fact that you're a woman. I'm going to forget the fact that you're of this age. Or I'm going to forget the fact that I know your family intimately. I am going to just tell you what is trending worldwide for this thing you've asked. They're both really, really important, valuable things to do. We have to be able to, we have to decide. We have to decide. Maybe we need to be able to choose between them. Maybe we should have rules about conventions so we can tell one from the other. So in general, those are some of my, if you like, some of the things I think of as being human rights on the internet. You will think of your own. You'll think of your own, in a way, some of these rights are rights which only really apply when you have a search engine. Before search engines really worked properly, your rights to have a neutral search didn't really exist. Is it a right now? Or should we just rely on net neutrality for the packets and rely on the market for search engines? It's all up for discussion. Let's have a big discussion about it this year. And then when we've decided what sort of a web we want, let's go and build that web, the web that we want, so we can use it to build the world that we want. Thank you.